Assalamualaikum warahmatullahi wabarakatuh. My name is DANIAL, and I'm as the first presenter for our group. Then I'm gonna talk about the application of differentiation that have been used for engineering in terms of calculated related rate. So we're moving to the next slide. Okay, on the next slide, we have our group members that I'm gonna introduce. So the first one is Muhammad MISHAL, the second one is KHAIRUL AZIM, the third one is Muhammad SYAFIQ, the fourth one is RAIHAN AZHARI, and the fifth one is me, ASYRAFF DANIAL. Okay, so on this slide, we have our table of content that contain four things, that is definition. The second one is the usage of differentiation in daily life. The third one is problem statement and solution. And the last one will be conclusion. So talk about differentiation. Many people will ask, what is differentiation? And so differentiation refers to the rate at which one quantity changes in relation to another. The rate of change of distance with respect to time is used to calculate speed. This speed at each instant is not the same as the calculated average. Differentiation is the ratio of a small change in one quantity to a small change in another that is dependent on the first. One of the most important concepts in calculus is the differentiation of a function. The maximum or minimum value of a function, the velocity and acceleration of moving objects, and the tangent of a function are all examples of functions. Differentiation is used to determine the shape of a curve. If y equal to function x and x is differentiable, the differentiation is denoted by f prime x or dy dx. And so we have moving on to the usage of differentiation in daily life. The differentiation enables us to calculate rates of change, where for an example, it enables us to calculate the rate of change of velocity with respect to time, which is acceleration. It also allows us to calculate the rate of change of x with respect to y, which is the gradient of the curve on a graph of y against x. So we will moving on to the example question where our next members will gonna talk and solve the problems.
Hey, my name is Ryan AZHARI. So I'm going to present the first example question. So the question is about an airplane is flying horizontally with a speed of 400 miles per hour at an altitude of 3 miles above a radar station. So how fast is the distance between the plane and the radar station changing when the plane is 5 miles away from the station? So we are going to show 5 steps how to solve the first question. So the first step, we are going to identify the given information. So the left side there's a diagram that we will draw. So we have 400 have been mentioned in the question, 400 miles per hour. So it will be our dy over dt, and dx over dt is 0 because the altitude above the radar station are not changing. So if the altitude change, so dx over dt also will be changed. So we're going to identify the altitude as x. So next is the distance between the plane and the radar station changing when the plane is 5 miles away. So we are going to substitute as q. So in step 1, we already identify the question and find out the important things. So in step 2, we are going to find the value y because we doesn't know yet y value. So we are going to use the theorem Pythagoras. So q power of 2 equals to y power of 2 plus x power of 2. So q is 5 and x is 3. So we are going to find y. So q power of 2 equals to y power of 2 plus x power of 2. So q is 5 and x is 3. So 5 power of 2 we get 25, and 9, 3 power of 2 we get 9. So we are going to square root both sides. So 16 square root we we get 4. So we are getting y is 4. So I'm going to pass to the next presenter to finish it step 3 until step 5.
Assalamualaikum warahmatullahi wabarakatuh. My name is KHAIRUL and I will continue in step D until step 5. So, in step D, we will find the equation that related the variable. So, based on the diagram in step 1, the diagram look like right of the angle. So, we will use the formula of right of the angle or theorem Pythagoras. So, after that, we are going to step 4. Step 4, we will differentiate the formula. So the formula is q power of 2 equal y over 2 plus x power of 2. So we multiply with d over dt. So we will get 2q dq over dt equal 2y dy over dt. So if you notice, s is missing here because we know the s over dt is equal to 0. So we got to put it at the equation. So 2 we will execute both sides because it's same. Then they become q dq over dt equal y dy over dt. Lastly, step 5 or final step, we will substitute all information. So we know the equation is q dq over dt equal y dy over dt. So we substitute q with 5, y substitute with 4, dy over t equal to 400. So 5 we move to right, it become divide. dq over dt equal 4 that multiply 400 and divide 5 with 5 and solve the equation, and the answer is 320 millimeter per hour. So that's all for me. I will pass to the next presenter. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is MUIZZUDDIN RAZALI and I'm going to explain the example question 2. So let's read out the questions. Two airplanes are about to intersect at a single point. The first plane is traveling west at 400 miles per hour and is currently 160 miles east from the convergence point. The second plane is traveling south at 750 miles per hour and is currently 300 miles north from the convergence point. At what is the distance between the two planes changing? So let's declare 160 miles as x and 400 miles per hour equals to dx over dt, and this is will be our y, and this is will be our dy over dt. So to the next, now to the next slide. All right, the first step is we have to draw a triangle. At this one, this is where the first plane points are, this is the second plane, and this will be our convergence point. Okay. Now we know that x is equal to 160, y is equal to 300, and z is the value that we need to find first to find dz over dt. Okay. dx over dt will be negative 400, dy over dt will be negative 750. Why is negative? Because the point are traveling to the convergence point, the distance are decreasing. That is why the value will be negative. So in order to find z over dt, we have to find the value of z first. Now look at this triangle. The triangles are right angle triangle, so we can find z using Pythagoras theorem. Now we just insert the value of x and y here. Now we can get z squared is equal to 115, and square root both of them, we will get z equals to 340, and that will be our z. I will now I will pass the next question, the next step to my friends MISHAL to complete the questions.
Assalamualaikum. My name is Muhammad MISHAL Adam IMAN and I will continue solution step 2. So, to find dz over dt, we have to differentiate the z square equals to x square plus y squared d over dt. After we differentiate, we will get 2z dz over dt equals 2x dx over dt plus 2y dy over dt. Notice that we have the number 2 on each equation. Then we can cancel out the number 2 and we get z dz over dt equals x dx over dt plus y dy over dt. We know that z is equals to 340, x equals to 160 and y equals to 300. So we can just insert the value into the equation. Also, we know that dx over dt equals to 400 and dy over dt is equals to negative 750. We can also insert the number into the equation. And we get dz over dt equals to negative 289,000 to divide with 340. And we get the answer dz over dt equals to negative 850 miles per hour. That's all for me.